Hello everyone, welcome to AAT concept video. My name is Narala Siddhartha. My roll number is 20951A6744. My branch is Computer Science Engineering with Data Sciences specialization. My subject is Design and Analysis of Algorithms. Today my topic is Time Complexity of Loop with Powers. So let's start. So I mainly divided the contents into two parts. In the first part, I am going to discuss about the time complexity and its basic meaning. In the second part, I am going to discuss about the time complexity of loops with the powers. So let's start. So time complexity, the basic idea about time complexity. Time complexity. Time complexity is the amount of time taken by an algorithm to run as a function of the length of the input. It measures the time taken to execute each statement of code in an algorithm. Upskilling with the help of an introduction to algorithms free course will help you understand time complexity clearly. Space and time define any physical object in the universe. Similarly, space and time complexity can define the effectiveness of an algorithm. While we know there is more than one way to solve the problem in programming, knowing how the algorithm works efficiently can add value to the way we do programming. To find the effectiveness of the program or algorithm, knowing how to evaluate them using spaces and time complexity can make the program behave in required optimal conditions, and by doing so it makes us efficient programmers. While we reserve the space to understand space complexity for the future, let us focus on the time complexity in this post. Time is money. In this fact post, you will discover a gentle introduction to the time complexity of an algorithm and how to evaluate a program based on time complexity. An algorithm in computer programming is a finite sequence of well-defined instructions typically executed in a computer to solve a class of problems or to solve a common task. Based on the definition, there needs to be a sequence of defined instructions that have to be given to the computer to execute an algorithm or perform a specific task. In this context, the variation can occur the way how the instructions are defined. There can be any number of ways a specific set of instructions can be defined to perform the same task. Also, with options available to choose any one of the available programming languages. The instructions can take any form of syntax along with the performance boundaries of the chosen programming language. We also indicated the algorithm to be performed in a computer, which leads to the next variation in terms of the operating system, processor, hardware, and etc. that are used, which can also influence the way an algorithm can be performed. Now that we know different factors can influence the outcome of an algorithm being executed, it is wise to understand how efficiently such programs are used to perform a task. To gain this, we require to evaluate both the space and time complexity of an algorithm. By definition, the space complexity of an algorithm quantifies the amount of space or memory taken by an algorithm to run as a function of the length of the input, while the time complexity of an algorithm quantifies the amount of time taken by an algorithm to run as a function of the length of the input. Now that we know why time complexity is so significant, it is time to understand what is the time complexity and how to evaluate it. By definition, the time complexity is the amount of time taken by an algorithm to run as a function of the length of input. Here, the length of the input indicates the number of operations to be performed by the algorithm. This gives a clear indication of what exactly time complexity tells us. It is not going to examine the total execution time of an algorithm. Rather, it is going to give information about the variation increase or decrease in execution time when the number of operations increase or decrease in an algorithm. Yes, as the definition says, the amount of time taken is a function of the length of input only. To elaborate, the time complexity measures the time taken to execute each statement of code in an algorithm. If a statement is set to execute repeatedly, then the number of times that statement gets executed is equal to the n multiplied by the time required to run that function each time. Rather, it is going to give information about the variation in execution time when the number of operations increase or decrease in an algorithm. Yes, as the definition says, the amount of time taken is a function of the length of input only. To elaborate, time complexity measures the time taken to execute each statement of the code in an algorithm. If a statement is set to execute repeatedly, then the number of times that statement gets executed is equal to n multiplied by the time required to run that function each time. So let's look at an example that is given below. So here we are executing this program by using Python program. So here in the below program we can see that a print statement is given in which this code is to be demonstrate time complexity is being printed there. So this is one statement of the code, and in order to execute one statement of the code, it takes nearly 1 millisecond. So here and another example is we have taken and chosen the for loop, and we have iterating the for loop with 10 times by taking the range as a 10. So inside this for loop we are printing a statement, and that statement in order to this for loop can be executed 10 times. So 10 times that statement will be executed, therefore the 10 times multiplied by the time taken by that statement. So hence that would be the time complexity of that statement. So the first time algorithm is defined to print the statement only once. The time taken to execute is shown as 0 nanoseconds, while the second algorithm is defined to print the same statement, but this time it is set to run the same statement in for loop for 10 times, as I have shown in the previous slide. In the second algorithm, the time taken to execute both the line of code for loop and print statement is 2 milliseconds, and the time taken increases as the value n increases, since the statement is going to get executed n times. By now you could have concluded that when an algorithm uses statements that gets executed only once, will require the same amount of time, and the when the statement is in the loop condition, the time required increases depending on the number of times the loop is set to run. And when an algorithm has a combination of both single executed loop statements and loop statements, or with nested loop statements, the time increases proportionally based on the number of times each statement gets executed. This leads us to ask the next question about how to determine the relation between the input and the time given a statement in an algorithm. To define this, we are going to see how statements gets executed and order of notation to describe time complexity, which is called big O notation. So as we can know that mainly the time complexity can be defined into further forms. These types are given below. They are constant time, linear time, logarithmic time, quadratic time, and cubic time, and many more such as exponential time and quasi-linear time, factorial time, etc. So let's understand the time complexity of a loop with the powers. Here there are mainly three cases of the time complexities found in any problem. Basically these three cases are based on the amount of times taken by that algorithm. They are best case. In the best case, the less time is taken by the loop to execute the given code, while as in average case, the average time, more not so worst and also not so best, and it is the average time that is taken by the that algorithm to execute, and the worst case is the maximum amount of time that algorithm could take to run that program. So here is the function which can be explained by the powers and with the nested loops inside it. So let's discuss about that. Here is the C program, and here we have taken a function which returns nothing, and it returns void, and we have taken two arguments into that, and both the arguments of ours are of integer type, and we designate them as n and k. And inside this function we have taken two for loops, and the first for loop is starts from the a variable 1 and ends when the variable is less than or equals to the given n variable in the function, and it increments until this condition satisfies. And inside this for loop we have taken a power function. This power function is used to find the power of the k value I with respect to the I. So inside this for loop we also found another for loop int j is equals to 1 and j is less than or equals to p and j plus plus, as we can understand. So it is another example we can find that, and here the time complexity of this code can be increased based upon this power, and we have used two for loops. Hence the time complexity of this code may be more complex when compared to others which contains a single for loop. Thank you.